Dr. Eleanor Wright tapped her pen nervously against her notepad as she waited outside the University Ethics Committee meeting room. Through the frosted glass door, she could see the silhouettes of the 12 committee members still discussing her proposal. They had been in there for over 2 hours now. Not a good sign. A janitor passed by, pushing his cleaning cart, and gave her a sympathetic smile. "Still waiting, Doc?" "Still waiting, Pete," she replied, trying to sound more confident than she felt. When she'd first submitted her research proposal 3 months ago, she knew it would raise eyebrows. But she hadn't expected this level of scrutiny. Then again, asking to put cameras inside coffins wasn't exactly conventional research. The door finally opened and Dr. Harriet Powell, the head of the ethics committee, gestured for her to come in. Eleanor gathered her papers and took a deep breath. The faces around the long oak table were serious, unreadable. "Dr. Wright," Harriet began, "we've reviewed your proposal thoroughly, and we have some concerns." Eleanor nodded, bracing herself for rejection. "However," Harriet continued, "we also recognize the potential scientific and environmental value of your work." For the next 20 minutes, Eleanor listened as the committee outlined their concerns and the strict guidelines they would require. When they finished, Harriet looked at her directly. "With those conditions in place, the committee has voted to approve your research, 7-5. Eleanor felt a rush of relief and excitement. "Thank you. I promise this research will be conducted with the utmost respect and scientific rigor." As she left the meeting room, her phone buzzed with a text from her research partner, Dr. Thomas Chen. "Well?" She texted back a simple thumbs-up emoji and headed to her office to share the news with her team. The Environmental Decomposition Research Lab was tucked away in the corner of the university's science building. It wasn't fancy. Just 3 adjoining rooms filled with equipment, soil samples, and more plants than most people would expect in a lab studying death. Eleanor had always believed that understanding death was really about understanding life's full cycle. Thomas was waiting for her, along with Dr. Amara Okafor and 2 graduate students. Their faces were anxious until they saw Eleanor's smile. "They approved it?" Thomas asked, jumping up from his chair. "With conditions, but yes, we got the green light," Eleanor confirmed. The team erupted in cheers. This wasn't just a research project for them. It was a mission. Conventional burial practices in many countries used harmful chemicals and materials that prevented natural decomposition and leached toxins into soil and groundwater. Their goal was to document what actually happens during natural decomposition, to help develop better, more environmentally friendly burial practices. The committee had concerns about privacy and respect for the deceased, of course, Eleanor explained as they gathered around the conference table. "We can only use volunteers who have explicitly donated their bodies for this specific research, with full family consent." "That's going to be our biggest challenge," Amara said, frowning slightly. "Finding people willing to participate." Thomas shook his head. "You'd be surprised. When I mentioned our research at that environmental conference last month, several people approached me afterward asking how they could volunteer their bodies after death." Eleanor nodded. People are becoming more environmentally conscious about everything, including what happens to their bodies after they die. Traditional burials use over 800,000 gallons of embalming fluid every year in this country alone, most of it containing formaldehyde, which is a known carcinogen. Not to mention the millions of feet of hardwood and tons of steel and concrete that get buried and never decompose naturally. "So what's our timeline?" asked Lily, one of the graduate students. "We need to finalize the camera design first," Eleanor said. "They have to be completely biodegradable themselves with non-toxic components, and they need to transmit data wirelessly for at least 6 months. "I've been working on a prototype," Thomas said, pulling up a design on his tablet. "Bamboo casing, biodegradable circuit boards, and a tiny solar cell that draws power from the specialized light we'll install at the gravesite, disguised as a memorial lamp." "What about the control sites?" Amara asked. "We'll need comparative data from traditional burials." Eleanor shook her head. "The committee vetoed that part. We can only study natural burials with biodegradable coffins. No embalming, no concrete vaults." "That actually makes sense," Thomas said. "If we're trying to document natural processes, We should focus on setups that allow those processes to happen. Their planning session was interrupted by a knock at the door. Eleanor opened it to find a middle-aged man in a tweed jacket, looking uncomfortable. "Dr. Wright? I'm Professor Alan Hartman from the Philosophy Department. Could I speak with you? For a moment, it's about your research." Eleanor exchanged a quick glance with her team. They'd expected pushback from religious groups and the funeral industry, but not from other academics. "Of course, come in." "I'm not here to criticize, Professor," Hartman said quickly, noticing their guarded expressions. "I'm here about my father, Richard Hartman. He passed away last week." "I'm sorry for your loss," Eleanor said automatically. "Thank you. My father was an environmental scientist himself, specializing in soil ecology. He followed your work and actually mentioned your research in his will." The professor reached into his satchel and pulled out a document. He specifically requested that if your study was approved, he wanted to participate. Eleanor took the paper with surprise. It was indeed a legal document stating Richard Hartman's wish to have his body used for environmental decomposition research, with specific mention of her project. "This is unexpected," she said, "but potentially very helpful for our research. Your father had remarkable foresight." Alan Hartman nodded. Dad was always thinking ahead. He specifically requested a green burial anyway. No embalming, bamboo, coffin, buried in the conservation section of Woodland Cemetery. When he read about your proposed research last year, he immediately added this codicil to his will. "And you're comfortable with this?" Amara asked gently. "I am," Alan said. "My father was passionate about environmental causes his entire life. He'd be pleased to know his death could contribute to science and potentially help change practices that harm the earth." After the professor left, the team sat in silence for a moment, absorbing this unexpected development. "Well," Thomas finally said, "I guess we have our first participant." Over the next month, preparations moved quickly. Thomas finalized the camera design, a slim, unobtrusive device that could capture time-lapse imagery and measure soil conditions. The data would transmit to a small receiver disguised as part of the grave marker. Eleanor met with Richard Hartman's family and the cemetery administrators to explain exactly what the research would entail. The Woodland Cemetery had already established a green burial section where bodies were buried without embalming, in biodegradable containers, and without concrete vaults, making it perfect for their study. "We want to be completely transparent," Eleanor explained to the Hartman family. "The cameras will document the natural decomposition process, which will include changes to the body. This data will help us understand how human remains can nourish the ecosystem, rather than harm it." Alan nodded. Dad would appreciate the scientific value. He always said death should be seen as transformation, not an ending. Richard Hartman's funeral was held on a Tuesday morning. Eleanor and her team attended out of respect, standing at the back of the gathering. It was a simple, dignified service, with many mentions of Richard's lifelong dedication to environmental causes. At the graveside, Eleanor noticed something unusual. Instead of cut flowers, attendees were sprinkling wildflower seeds onto the bamboo coffin. It was his request, Alan explained when he saw Eleanor watching. Dad said he wanted to feed the flowers directly. After the funeral, when the family had left, Eleanor's team went to work installing their equipment. The camera was carefully positioned inside the coffin before burial, and the receiver was installed as part of the simple wooden grave marker. To casual observers, it would appear to be nothing more than a decorative element. "System check?" Eleanor asked as Thomas tapped on his tablet. "All green," he confirmed. "We're receiving data transmission. Camera 1 is online and recording." Eleanor looked down at the freshly covered grave. From the outside, it looked like any other burial site, distinguished only by the lack of elaborate headstone and the simple wooden marker. No one would guess that beneath the soil, a scientific revolution was about to begin.
"Now we wait," she said. "How long until we start seeing results?" Lily asked. "The natural decomposition process begins immediately," Amara explained, "but visible changes that our cameras can detect might take weeks or months, depending on soil conditions, temperature, and other factors."
As they walked back to their van, Eleanor noticed a man watching them from beside a large oak tree. He wore an expensive suit and had the unmistakable look of a funeral industry executive. He didn't approach them, but his disapproving stare made his feelings clear. "I think word is getting out about our research," Thomas murmured. "Good," Eleanor said firmly. "This isn't something that should happen in secret. If we're going to change how people think about death and burial, we need to be open about what we're doing. Still, we should be prepared for opposition," Amara warned. "There's a lot of money in traditional funeral practices. Some people won't be happy about research that might threaten that." Eleanor nodded, but remained resolute. As they drove away, from the cemetery, she glanced back at Richard Hartman's grave. Above it, the simple wooden marker caught the afternoon sunlight, giving no hint of the groundbreaking research happening beneath. Little did she know that what they would discover in the coming months would challenge everything science thought. It knew about what happens after we die, and would change her own understanding of the thin boundary between life and death. 3 months passed quickly. The research team had expanded their study to include 5 different burial sites, each with varying soil conditions and coffin materials. Weekly data collection had become routine, with team members taking turns visiting the cemeteries to download information from the receivers and check that everything was functioning properly. Zoe Patterson yawned as she stared at her computer screen. As the newest research assistant on the team, she'd been assigned the task of reviewing hours of time-lapse footage from the cameras. Not the most exciting job, but necessary. Most of the videos showed exactly what they expected. The slow natural processes of decomposition, important for their research certainly, but after watching for 6 hours straight, Zoe's eyes were growing tired. She reached for her coffee mug, found it empty, and sighed. Just one more video to review before she could call it a day. She clicked on the file labeled Hartman Week 12. At first, the footage looked similar to what she'd been watching all day. Then something caught her eye. She leaned closer to the screen, rewound the video, and played it again at a slower speed. "That can't be right," she muttered, adjusting her glasses. She picked up her phone and dialed Dr. Wright. "Eleanor? It's Zoe. I think you need to see this." 30 minutes later, the entire research team crowded around Zoe's computer screen, watching in fascination as she played the footage again. "Look there," Zoe pointed. "The movement starts around the 72-hour mark of this week's recording. It's subtle at first, but then..." On the screen, they could clearly see small insects entering the bamboo coffin through tiny, natural gaps in the material. This wasn't surprising. Insects were expected to be part of the decomposition process. What was surprising was the sheer number and variety, and how quickly they had established what appeared to be organized patterns of movement. "The biodegradable coffin is breaking down much faster than we predicted," Dr. Chen observed. "See how the bamboo fibers are already separating? That's at least 2 months ahead of schedule based on our models." Dr. Okafor pointed to another area of the screen. "And look at the soil interaction. The boundary between the coffin and the surrounding earth is almost completely permeable already." Eleanor nodded, her excitement growing. "This is remarkable. The natural systems are integrating with the burial site much more efficiently than we hypothesized." But the most surprising discovery came when Zoe fast-forwarded to the end of the week's footage. "Wait," Thomas said suddenly. "What's that?" Zoe paused the video and zoomed in on a small area near the edge of the frame. There, barely visible at first, were tiny white filaments extending from several small objects. "Are those..." Amara leaned closer. "Seeds," Eleanor confirmed. "The wildflower seeds that were scattered during the burial. They're germinating inside the coffin." Thomas looked puzzled. "But how? There's no sunlight down there." "They don't need sunlight to germinate," Lily explained. "Many seeds just need moisture and the right temperature to start sprouting. Once they break the surface, then they'll need sunlight to grow. But what's fascinating," Eleanor added, "is that they're germinating so quickly in that environment. They're drawing nutrients directly from the decomposition process." The team spent the next few hours reviewing footage from the other burial sites, but none showed the same level of activity as Richard Hartman's grave. What's different about the Hartman site? Zoe wondered. For one thing, it's the only one where seeds were deliberately introduced during the burial, Thomas pointed out. The others have only whatever plant material was naturally present in the soil. Also, Woodland Cemetery's green burial section is in a more wooded area, Amara added. The soil is likely richer in organic matter to begin with. We need to collect soil samples from all sites for comparison, Eleanor decided. And I want to increase our monitoring frequency for the Hartman site. Whatever's happening there, it's happening much faster than we anticipated. The next morning, the team headed to Woodland Cemetery. The day was overcast, a light drizzle making the grass slick beneath their boots. They carried equipment that looked to casual observers like standard groundskeeping tools, a clever disguise for their soil sampling kits. As they approached Richard Hartman's grave, Eleanor was surprised to see a small patch of green already emerging from the soil mound. "Look at that," she whispered, kneeling down. "Wildflowers, already breaking through." Thomas checked his tablet. "It's been exactly 12 weeks and 3 days since the burial. That's incredibly fast growth. The flowers shouldn't even know which way is up yet," Lily said, examining the tiny sprouts. "Normally they'd grow randomly until they found sunlight." "But they're not growing randomly," Amara observed. "They're all growing straight up, as if they know exactly where to go." Eleanor carefully took soil samples from around the sprouting flowers, making sure not to disturb them. "Let's check the camera feed while we're here. I want to see if there's anything new since yesterday's footage." Thomas connected his tablet to the receiver hidden in the grave marker and downloaded the most recent data. His eyes widened as he scrolled through the new images. "You need to see this," he said, turning the screen so the others could view it. The newest footage showed an explosion of microbial activity within the coffin. The camera's infrared capabilities revealed heat signatures that indicated intense biological processes underway. "It's like the whole system has suddenly accelerated," Thomas said. "The decomposition rate has increased by nearly 200% in just the last 24 hours. "That shouldn't be possible," Amara shook her head. "Nothing in our understanding of decomposition processes accounts for this kind of rapid change. Unless," Eleanor said slowly, a new idea forming, "the system has reached some kind of critical mass, like a tipping point where enough biological activity is present to create a self-reinforcing cycle." As they discussed possibilities, a groundskeeper approached on a small utility vehicle. He nodded to them casually. "Morning, folks. You at the university study?" Eleanor straightened up. "Yes, we're collecting some follow-up data. I hope that's all right." "No problem," the man said. "Director told us to give you whatever help you need. I'm actually glad you're here. I wanted to ask about that grave." He pointed to Richard Hartman's plot. "The flowers coming up already. That normal?" "We're trying to figure that out ourselves," Eleanor admitted. The groundskeeper nodded. "Been working here 22 years, and I've never seen growth that fast, especially not in this soil. The whole green burial section seems different lately, greener somehow." After he drove away, the team collected the rest of their samples and headed back to the lab. They spent the rest of the day analyzing the soil and reviewing the new footage. Under the microscope, the soil samples revealed something remarkable. "The microbial diversity is off the charts," Lily reported. "I'm seeing species that typically wouldn't appear until much later in the decomposition process, and some I can't even identify yet. The nitrogen and phosphorus levels are extremely high," Thomas added, looking up from his analysis. "But it's not just concentrated around the burial site. It's distributed evenly throughout the surrounding soil, as if something is actively moving the nutrients outward," Eleanor mused. Later that evening, as the others were packing up to leave, Zoe remained hunched over her computer, reviewing more footage. "Go home, Zoe," Eleanor said gently. "The dead will still be dead tomorrow." Zoe didn't smile at the weak joke. "I want to check one more thing. I noticed something in the infrared footage." Eleanor sat down next to her. "What is it?" "Watch the heat signatures at the edges of the frame," Zoe said, playing the video. "See how they pulse? Almost like a heartbeat," Eleanor finished, leaning closer. "But that's not possible. Not a human heartbeat, Zoe clarified quickly. But some kind of rhythmic energy transfer, like the system itself is pulsing. They watched in silence as the pattern repeated, a wave of heat and activity that spread from the center of the coffin outward, then retreated, then spread again, in a regular rhythm. I've never seen anything like this in decomposition studies, Eleanor admitted. It's almost as if... As if what? Zoe prompted when Eleanor didn't continue. Eleanor hesitated, aware of how strange her thoughts would sound. As if the entire gravesite has become a single, coordinated organism, not just separate decomposers doing their individual jobs, but a unified system working together. The next morning, the team met early to discuss their findings and plan. Next steps. We need to expand our monitoring, Eleanor decided. I want underground soil sensors placed in a grid extending at least 10 meters in each direction from the Hartman grave. What exactly are we looking for? Thomas asked. Eleanor projected an image onto the wall screen, the pulsing heat pattern Zoe had discovered. This rhythm suggests energy is being distributed throughout the system. I want to know how far it extends and whether it's affecting neighboring areas of the cemetery. I've been thinking about the wildflower seeds, Lily added. They're growing so quickly because they have direct access to nutrients from the decomposition. But what happens when they break the surface and start photosynthesizing? Will they then start feeding energy back into the system? A closed energy loop, Amara nodded. Fascinating possibility. I've also noticed something in the latest soil samples, Thomas said, bringing up his data. The fungi content has increased dramatically, specifically mycorrhizal fungi, the type that forms symbiotic relationships with plant roots. Creating underground networks, Eleanor said, the implications dawning on her. Nature's internet. Exactly, Thomas nodded. These fungi can connect plants to each other, allowing them to share nutrients and even information. The team looked at each other, the magnitude of what they might be witnessing sinking in. We need to be careful about how we present this, Amara cautioned. The scientific community is going to be skeptical, to say the least. Which is why we need irrefutable data, Eleanor agreed. Let's expand the monitoring network and keep this quiet for now, at least until we're sure of what we're seeing. As, they left the meeting to prepare their expanded monitoring equipment. Eleanor felt a mix of scientific excitement and something deeper, more profound. They had set out to document decomposition to help develop better burial practices. But they might have stumbled onto something much more significant, evidence that human remains, when allowed to decompose naturally, don't just return to the earth, but actively participate in creating new life in ways they had never imagined. The boundary between life and death, it seemed, was far less clear than anyone had thought. 6 months into the study, Woodland Cemetery had become like a second home to the research team. They visited at least twice a week, sometimes more, carefully monitoring the changes at Richard Hartman's grave and the surrounding area. What had started as a small patch of wildflower sprouts had transformed into a lush garden of blooms, more vibrant than anything else in the cemetery. The groundskeeper says visitors keep asking about this section, Thomas told Eleanor as they set up additional monitoring equipment one misty morning. They want to know what special fertilizer they're using. Eleanor smiled, kneeling to examine a particularly bright cluster of purple coneflowers. If only they knew the truth. Their expanded monitoring system was now providing data that left them both excited and bewildered. Underground sensors had confirmed what they'd begun to suspect. Something extraordinary was happening beneath the surface. Back at the lab that afternoon, the team gathered to review the latest findings. Eleanor dimmed the lights, and a 3-dimensional, holographic map appeared above the conference table, showing the underground network they'd discovered extending from Richard Hartman's grave. This is what we've mapped so far, she said, pointing to the glowing blue lines that spread outward from the central point of the grave. These are root systems and fungal networks, extending much farther than we initially thought possible. How far do they reach now? Lily asked, leaning forward to study the map. The furthest extension is nearly 40 feet from the grave, Thomas replied. They've connected to 3 mature oak trees, several younger saplings, and even crossed into the traditional burial section of the cemetery. But they stop at the concrete vaults around traditional graves, Amara noted, pointing to areas where the blue lines abruptly ended. They can't penetrate those barriers. Zoe tapped a few keys and the hologram changed, now showing heat signatures and nutrient flows in red. This is even more interesting. Watch what happens over a 24-hour cycle. The team watched in silence as the visualization showed pulses of red flowing outward from the grave, through the blue network, reaching the trees and other plants, then flowing back again in a continuous cycle. It's like a heartbeat, Lily whispered. More like breathing, Thomas suggested. An inhalation and exhalation of nutrients and energy. Whatever we call it, it's unprecedented, Eleanor said. The network is transporting nutrients from the decomposition process to surrounding plants, and then something is flowing back to the gravesite. Sugars and carbohydrates, Amara explained. The plants photosynthesize, creating energy from sunlight, and then share some of that energy back through the network. It's a completely closed-loop system. But why? Zoe asked. Why would plants send resources back to a grave? Because they're not just sending them to the grave, Thomas said, his voice filled with wonder. They're feeding the network itself. The mycorrhizal fungi connecting everything acts as a living internet. It requires energy to maintain itself. So, the whole system is self-sustaining, Eleanor concluded. The human remains provide an initial nutrient boost that kickstarts the network, the plants benefit and grow stronger, and then they feed the network that connects them all. Lily had been quiet, studying a different set of data on her tablet. There's something else, she said finally. The soil samples from around the gravesite show significantly higher carbon sequestration than control sites. How much higher? Thomas asked. Almost 300%, Lily replied. If these results hold up, it suggests that this kind of burial practice could actually help fight climate change on a meaningful scale. The team sat in stunned silence, absorbing the implications. We need to verify these findings, Eleanor said finally. I want to run more tests, gather more data. If what we're seeing is real, it could change everything about how we approach burial practices. I've been thinking, Amara said slowly. What if we used a special camera filter to visualize the nutrient flow more clearly? Something that could show us exactly what's moving through the network and in which direction. That's brilliant, Thomas agreed. I can modify one of our camera units with a spectral filter that should let us see different compounds based on their molecular structure. 2 days later, they were back at the cemetery with the modified camera. The wildflowers above Richard Hartman's grave were now in full bloom, creating a stunning display of purples, yellows, and whites that stood out vividly against the more subdued landscaping of the rest of the cemetery. His family visited yesterday, the groundskeeper told them as he passed by on his rounds. They were amazed by the flowers, said Mr. Hartman would have loved it. Eleanor nodded, thinking how right he was. Richard Hartman had given them far more than just permission to study his remains. He had given them a window into a profound, natural process that few had ever witnessed. Thomas carefully positioned the modified camera on a small tripod near the grave. This should give us a clear view of the root systems just below the surface, he explained. If the filter works correctly, we'll be able to see different nutrients highlighted in different colors. They waited as the camera processed the information, converting what it saw into a visual image they could understand. When the picture finally appeared on Thomas's tablet, they gasped collectively. The screen showed a network of glowing, pulsing connections just beneath the soil surface. Different colors moved through the system like rivers flowing in multiple directions, phosphorus glowing blue, nitrogen appearing green, carbon compounds showing as red, and various minerals in yellows and purples. It's beautiful, Lily whispered. It's more than beautiful, Eleanor said, her voice filled with emotion. It's life and death working together exactly as nature intended. As they watched, the flow of nutrients from the grave site intensified, sending a surge of rich compounds outward, through the network. Moments later, they saw a corresponding pulse coming back, energy from the plants flowing inward. I've never seen anything like this. Amara shook her head in wonder. The exchange is so perfectly balanced. Thomas moved the camera slowly, following one of the main channels of the network toward a nearby oak tree. As the camera's view reached the tree's base, they saw how the nutrient flows connected directly to the tree's root system, merging with it. The tree is part of the network too, he confirmed. And look, it's sending back more energy than it's receiving. It's acting like a hub, redistributing resources throughout the system. Eleanor thought about the implications. Trees have been here much longer than us. They've developed sophisticated ways of communicating and sharing resources. What we're seeing is a human body becoming part of that ancient system. Not just becoming part of it, Amara corrected, enhancing it. The nutrients from Richard Hartman's remains have supercharged this local ecosystem. They continued mapping the network, discovering it had connected to every plant within 50 feet of the grave and was still expanding. Most surprising was how the fungi seemed to be selectively connecting certain plants while bypassing others. It's making choices, Thomas realized. The network is forming specific connections, not just spreading randomly. When they returned to the lab to analyze their findings, Zoe made another startling discovery. I've been comparing our data with the cemetery's plant records, she said, bringing up a map on the main screen. Look at this. The network is preferentially connecting to native plant species while mostly ignoring non-native ornamentals. That makes sense from an evolutionary perspective, Amara nodded. Native plants and fungi have co-evolved over thousands of years. They would have more established relationships. But there's more, Zoe continued. One of the strongest connections is to this small patch of prairie blazing star flowers. According to the records, they're an endangered species that the cemetery has been trying to re-establish. Let me guess, Eleanor said. The network is providing extra resources to those endangered plants? Exactly, Zoe confirmed. They're receiving nearly twice the nutrient flow of other plants, and they're thriving, blooming earlier and producing more flowers than expected. Thomas leaned back in his chair, processing the implications. So the network isn't just redistributing resources randomly. It's prioritizing biodiversity and supporting vulnerable species. It's like the ecosystem has its own intelligence, Lily suggested. A way of protecting itself by maintaining diversity. Eleanor considered this. Not intelligence as we understand it, but a kind of ecological wisdom that's evolved over millions of years. Systems that promote biodiversity tend to be more resilient, so they survive while others fail. And when we bury people in ways that block this process, with embalming chemicals, metal caskets, and concrete vaults, we're cutting ourselves off from this ancient system, Amara added. We're not just harming the environment, Eleanor agreed. We're denying ourselves the chance to contribute to life after death. As the sun set outside the lab windows, casting long shadows across their data displays, the team sat quietly, each absorbed in their own thoughts about what they'd discovered. What do we do with this information? Lily finally asked. Eleanor looked at each of her team members in turn. We share it, she said firmly. We document everything meticulously, submit our findings for peer review, and show the world what happens when we allow natural processes to occur. There will be resistance, Thomas warned. The funeral industry, religious groups. Probably, Eleanor acknowledged. But we have something powerful on our side. What's that? Zoe asked. Eleanor smiled, thinking of the vibrant flowers blooming above Richard Hartman's grave, of the intricate pulsing network spreading beneath the soil, connecting death to new life in a continuous cycle. Truth, she answered simply. And it's beautiful. Eleanor took a deep breath before clicking Submit on her computer. The team's preliminary findings, carefully documented and reviewed, were now on their way to the Journal of Environmental Science. They had decided to publish in a respected but more progressive scientific journal that might be open to their unconventional research. It's done, she announced to the team, who had gathered in the lab for this moment. Now we wait. How long? Until we hear back? Zoe asked, perching on the edge of a lab stool. Normally, peer review takes months, Thomas explained. But given the nature of our findings, they might fast-track it. They didn't have to wait long for reactions, though not from the scientific community. The very next day, Eleanor received a call from the university's public relations director. "Dr. Wright," he said, his voice tense. "Did you authorize a press release about your burial research?" "No," Eleanor replied, confused. "We just submitted to a journal yesterday. We wouldn't release anything to the press before peer review." "Well, someone did. It's all over social media this morning. The headline is, 'University Scientists Place Cameras in Coffins, Discover Life After Death.'" Eleanor's stomach dropped. "That's not what our research shows at all. We never use that phrase." Nevertheless, my phone's been ringing non-stop. Religious groups, funeral industry representatives, environmental activists, everyone wants a comment. After hanging up, Eleanor quickly gathered her team. The situation was worse than she'd feared. Someone had leaked a sensationalized version of their research, complete with out-of-context quotes and misleading interpretations. "This is a disaster," Amara said, scrolling through news articles on her tablet. "They're completely misrepresenting our findings." "Who would do this?" Lily wondered. Thomas looked grim. "Remember that funeral industry representative we spotted watching us at the cemetery? My guess is they got wind of our research and decided to control the narrative before we could publish." By making it sound like pseudoscience, Eleanor nodded. Classic discrediting tactic. By afternoon, the university was holding an emergency meeting with Eleanor and her team. The room was packed with administrators, legal counsel, and public relations staff, all wearing expressions ranging from concern to outright alarm. "The Board of Trustees is deeply concerned," the university president said. "We've received calls from major donors threatening to withdraw funding. Several religious organizations are planning protests on campus tomorrow." "We haven't done anything wrong," Eleanor insisted. "Our research is sound, ethical, and fully approved by the university." "But the perception is what matters now," the PR director countered. "The public is hearing that we're desecrating graves and making wild claims about life after death." "We've never claimed anything about life after death," Eleanor said firmly. "Our research shows that natural decomposition creates beneficial interactions with the surrounding ecosystem. It's about environmental science, not spirituality." "Nevertheless," the president said, "the board is considering whether to continue supporting this research." Eleanor felt her heart sink. After all their careful work, all their groundbreaking discoveries, it could all be shut down because of a misleading leak. As the team left the meeting, Thomas's phone rang. It was a reporter from the National Science Times. "Dr. Chen? I'm hoping to get your comment on the burial research controversy. Is it true that your team has evidence of consciousness continuing after death?" Thomas nearly dropped his phone. "Absolutely not. That is not what our research shows at all." "But your team placed cameras in coffins and recorded activity, correct?" "Yes, but..." "And you observed organized patterns that couldn't be explained by normal decomposition?" "The patterns are explained by biological interactions between decomposing remains, soil microbes, fungal networks, and plant roots. It's fascinating. Science, but it's not supernatural." After hanging up, Thomas looked at Eleanor in dismay. This is going to get worse before it gets better. He was right. By evening, social media was ablaze with opinions about research most people hadn't even read. Religious leaders condemned the study as sacrilegious. Funeral industry spokespeople called it junk science designed to attack traditional burial practices. Environmental groups praised the research but often misinterpreted the findings to suit their own messaging. The next morning, a small crowd of protesters gathered outside the science building, carrying signs with slogans like "Let the dead rest in peace" and "Stop playing God." Eleanor stood at her office window, watching the scene with a heavy heart. "We should have been more careful about security," she said as Thomas joined her. "We knew this research would be controversial. We couldn't have predicted this level of misrepresentation," he reassured her. "But we need to get ahead of this somehow. Set the record straight." Eleanor's phone buzzed with a text message. It was from Alan Hartman, Richard's son. "Seeing the news about your research. Would like to speak with you. Can you meet today?" Eleanor felt a pang of guilt. The Hartman family had trusted them with Richard's remains, and now they were at the center of a media firestorm. I need to meet with Alan Hartman, she told Thomas. His family deserves to hear directly from us what's going on. They arranged to meet at a quiet cafe off campus to avoid the protesters and reporters. Alan was already waiting when Eleanor arrived, a newspaper folded on the table in front of him. Dr. Wright, he greeted her, standing to shake her hand. Thank you for meeting me. Eleanor steeled herself for anger or accusations, but Alan's expression was hard to read. Mr. Hartman, I want to apologize for the media circus. Someone leaked a distorted version of our research and it's gotten completely out of hand. Alan nodded slowly, then surprised her with a question. Is it true that my father's grave has wildflowers growing more vigorously than anywhere else in the cemetery? Yes, Eleanor confirmed. The natural burial process has created a remarkably fertile environment. And these networks you've discovered, the roots and fungi connecting his grave to other plants, they're really there? You have evidence? Extensive evidence. Multiple imaging techniques, soil samples, nutrient analysis. It's all scientifically documented. Alan sat back, a thoughtful expression on his face. My father would have loved that, he said finally. He always talked about the interconnectedness of all living things. The idea that he's now physically part of that network would have delighted him. Eleanor felt a wave of relief. You're not upset about the research? Why would I be? This is exactly what my father wanted, to contribute to science and to the earth. Alan leaned forward. In fact, I think my father should have a voice in this debate. What do you mean? I mean, I'd like to speak publicly about why my father chose to participate in your study. Put a human face on this research. If people understand the person behind the science, his values, his wishes, maybe they'll see this differently. Eleanor considered this. That could be incredibly powerful, but are you sure? The media attention could be intense. Alan nodded firmly. I'm sure, and I'm not alone. That afternoon, Alan Hartman held a press conference on the steps of the university's science building. Eleanor and her team stood nearby, nervous but hopeful. My name is Alan Hartman, he began, his voice strong despite the crowd of reporters and protesters. The grave at the center of this controversy belongs to my father, Richard Hartman. He was an environmental scientist who dedicated his life to understanding and protecting our natural world. The crowd quieted as Alan continued, showing a photo of his father, a kind-faced man with gray hair and laughing eyes. My father specifically requested to be part of this research. He believed that our modern burial practices harm the environment and disconnect us from natural cycles. The findings from Dr. Wright's team would not have shocked or offended him. They would have fascinated and delighted him. Alan explained his father's environmental values and his deliberate choice to have his remains studied. As he spoke, other families joined him, relatives of the other research participants all expressing support for the study. My mother wanted her body to nourish the earth, not be sealed away from it, said an older woman, stepping forward. She would have been proud to be part of this research. My brother was only 26 when he died of cancer, a young man added. He chose to participate in this study because he wanted something positive to come from his death. These findings are his legacy. One by one, family members shared personal stories, transforming abstract research subjects into real people who had made conscious choices about their final contribution to the world. Reporters, who had come expecting controversy, found themselves documenting something very different. A powerful human story about choice, meaning, and connection to the natural world. When Alan finished speaking, he turned to Eleanor. Would you like to address the scientific findings directly, Dr. Wright? People should hear the truth from you. Eleanor stepped up to the microphones, nervous but determined. Our research has never been about the supernatural or any kind of consciousness after death, she clarified. What we've discovered is that when bodies are allowed to decompose naturally, they become part of a remarkable living network in the soil. She explained in simple terms how fungal networks connected plants to one another, how nutrients flowed through these networks, and how natural burials enhance this process rather than disrupting it. What happens after death isn't mysterious or frightening, she concluded. It's beautiful. We become part of the cycles that sustain all life on Earth. Mr. Hartman and our other participants haven't lived on, in any supernatural sense. They've returned to the Earth exactly as nature intended, nourishing new life around them. As the press conference ended, Eleanor noticed the protesters had grown quieter, some even listening intently. A few reporters were asking thoughtful questions rather than seeking sensationalism. It was a small shift, but an important one. Later, as the team walked back to the lab, Thomas turned to Eleanor. "Do you think we made a difference today?" Eleanor looked back at the dispersing crowd. "I think we started a conversation, and that's always the first step toward change." That evening, as Eleanor checked her email one last time before heading home, she found a message from the journal editor. "Dr. Wright, in light of the public interest in your research, we're expediting the peer review process. Initial feedback from reviewers is positive, though they have questions about methodology. Please stand by for formal comments. This work could be groundbreaking if it holds up to scrutiny." Eleanor smiled tiredly. The controversy was far from over, but at least now their actual research would be part of the conversation. They had science on their side, and thanks to Alan Hartman and the other families, they now had powerful human stories as well. Sometimes, she reflected, the most important discoveries face the greatest resistance. But truth has a way of taking root and growing, much like the networks they had discovered beneath the cemetery grounds, quietly, persistently, and with surprising strength. 1 year later, Eleanor stood at the podium in the university's largest lecture hall, which was packed to capacity. The crowd was a diverse mix: scientists, students, environmentalists, funeral industry professionals, and families who had followed their research journey. Outside, a live feed was set up for the overflow crowd who couldn't fit inside. "Thank you all for coming today," Eleanor began, looking out at the sea of faces. 1 year ago, our team set out to study a simple question: what happens when we allow natural processes to occur after death? Today, we're presenting our complete findings and their implications for how we think about our relationship with the Earth. Behind her, a large screen displayed the title of their presentation: Legacy Ecosystems, How Natural Burial Creates Environmental Renewal. So much had changed in a year. After the initial controversy died down, their research had undergone rigorous peer review. There had been skepticism, certainly, but as more scientists examined their data, support grew. 3 independent research teams had now replicated their key findings at different sites across the country. "I want to begin by thanking the families of our research participants," Eleanor continued. "Their courage in sharing their stories helped transform a scientific debate into a human conversation about choices and values." Alan Hartman, sitting in the front row, nodded in acknowledgement. Beside him sat members of other participant families, many of whom had become vocal advocates for natural burial options. "Let me show you what 1 year of observation has revealed," Eleanor said, signaling to Thomas to start the presentation. The screen displayed a time-lapse sequence from Richard Hartman's gravesite, showing the complete transformation that had occurred over 12 months. What had begun as bare soil had become a lush, thriving ecosystem of native plants, with wildflowers in all colors spreading beyond the original gravesite. "This is not just a cosmetic change," Eleanor explained. "Our sensors have documented significant improvements in soil health, biodiversity, and carbon sequestration in these areas." Thomas took over the presentation, explaining the technical aspects of their findings. "The fungal networks we discovered have now expanded to connect over 100 plants across a 70-foot radius," he explained, showing mapping imagery that revealed the vast underground connections. "What's most remarkable is how these networks have strengthened the entire local ecosystem." Amara stepped forward to discuss the environmental implications. "Traditional burial practices in the United States use over 30 million board feet of hardwood, 2,700 tons of copper and bronze, 104,000 tons of steel, and 1.6 million tons of concrete annually," she explained, letting those numbers sink in. "All These materials are sealed away from the natural cycles that could reuse them. The presentation continued with Zoe showing data on how the mycorrhizal fungi networks facilitated nutrient sharing between plants, allowing struggling species to receive support from stronger ones. It's a natural mutual aid system, she explained. Resources flow where they're needed most. We've documented endangered plant species thriving in these networks at rates far exceeding their normal survival rates. Lily presented their most recent discovery, evidence that these enhanced soil networks were significantly more resistant to drought, disease, and invasive species. These legacy ecosystems, as we now call them, show remarkable resilience, she explained. They're healthier and more adaptive than surrounding areas. As the technical portion of the presentation concluded, Eleanor returned to the podium. Science is about facts and data, she said, but it's also about meaning. What do these findings mean for us as humans, as part of the natural world? She clicked to a new slide showing a simple diagram of a circle. For most of human history, we understood death as part of a cycle. Our bodies return to the earth, nourishing new life. Modern burial practices have interrupted that cycle, sealing bodies away from the natural processes that recycle all life. Eleanor paused, looking out at the audience. What our research suggests is that we haven't just harmed the environment with these practices. We've robbed ourselves of our final contribution to the living world. The hall was silent as Eleanor's words sank in. I'd like to invite someone up who can speak to this more personally, Eleanor said. Alan Hartman, whose father's burial site became the centerpiece of our research. Alan walked to the podium with measured steps. He was dressed simply in a navy sweater and khaki pants, looking more like a kind professor than the philosophy department chairman he was. My father loved the woods, Alan began, his voice gentle but carrying clearly through the hall. He would spend hours identifying every plant, every insect, every bird call. He understood that he was just one small part of an incredibly complex living system. Alan clicked to a new slide showing a photo of his father in hiking gear, smiling, broadly beside an ancient oak tree. When he was diagnosed with cancer, one of his first concerns was what would happen to his body. Not out of vanity or fear, but because he wanted his final act to be giving back to the earth that had sustained him for 72 years. Alan scrolled through several photos, Richard Hartman camping with family, teaching students in the field, examining soil samples in a lab. When Dr. Wright's team approached us about their research, it felt like an answer to a question my father had been asking his whole life. How can humans live and die in better harmony with natural systems? Alan turned to look at the current image on the screen, a photo taken just a week ago of his father's gravesite, now a vibrant patch of wildflowers and native grasses. What you're looking at isn't just flowers growing over a grave, Alan said. It's my father's last gift to the world. The nutrients from his body have helped create this thriving ecosystem. The carbon that was once in his cells is now in these plants. In a very real scientific sense, he continues to participate in the web of life. When Alan finished speaking, a young woman rose from her seat. My mother participated in your study too, she said. She died of ALS last year. Seeing what's happened at her burial site has helped our family with our grief. It's like she's still creating beauty in the world. Others began to share similar experiences, how watching life flourish from their loved ones' remains had provided comfort and a sense of ongoing connection. As the formal presentation ended and people began to mingle, Eleanor found herself approached by a man in an expensive suit, someone she recognized as a representative from one of the largest funeral home chains in the country. Dr. Wright, he said, extending his hand. That was quite compelling. We've been following your research with interest. Really? Eleanor couldn't hide her surprise. The conventional funeral industry had been among their strongest critics initially. Consumer demand is shifting, he explained. More families are asking about green burial options. We need to adapt or be left behind. I was hoping we might discuss a potential collaboration, developing standards for natural burial practices that could be implemented more widely. Before Eleanor could respond, she noticed another visitor waiting nearby, a gray-haired woman she didn't recognize. Dr. Wright? The woman said hesitantly. I'm Beth Williams. My husband is dying of heart failure. He has maybe 6 months. After reading about your research, he's decided he wants a natural burial. I wanted to ask, could he participate in your ongoing studies? By the end of the day, Eleanor had spoken with dozens of people, scientists interested in expanding the research, landowners wanting to establish natural burial grounds, families seeking meaning in their end-of-life choices, and even religious leaders curious about how these practices might align with their traditions of stewardship and care for creation. As the crowd finally thinned, the research team gathered in a quiet corner of the now-empty hall. I think we've started something much bigger than a research project, Thomas said, looking around at his colleagues. Amara nodded. People are hungry for better ways to live and better ways to die. Our research is giving them a new option. Or actually, a very old option, Lily corrected with a smile. We're just helping people rediscover what their ancestors knew. Eleanor's phone buzzed with a message from the dean. The university had just received a major grant to establish a center for natural burial studies, with Eleanor named as the inaugural director. It seems our work is just beginning, she told the team, showing them the message. Later that evening, as the sun was setting, Eleanor made one last stop before heading home. She drove to Woodland Cemetery and walked to Richard Hartman's gravesite. The wildflowers were closing for the night, but the area hummed with life. Bees making final visits to blossoms, birds calling from nearby trees, the rustle of small animals moving through the undergrowth. She knelt down and placed her hand on the soil, feeling its warmth. Warmth generated by countless microorganisms and fungi going about their ancient work of transformation. Thank you, she whispered, not just to Richard Hartman, but to all their research participants who had given one final gift to science and to the earth. As she stood to leave, Eleanor noticed a family a few rows away, placing wildflower seeds on a fresh grave in the green burial section, a section that had tripled in size over the past year, as more people chose this option. The boundary between life and death, Eleanor reflected, had never really been as stark as modern practices made it seem. Death wasn't an ending but a transformation, a return to the cycles that sustain all life on Earth. What their cameras had captured wasn't just decomposition but reconnection, humans becoming part of something larger, more enduring, and ultimately, more hopeful than individual existence. It wasn't immortality in the traditional sense. It was something both simpler and more profound, belonging, at last and forever, to the earth that had always been our home.